Hey guys, welcome back. Last video we talked about the derivative function or the gradient function, which is the gradient of the tangent to a function at each point on the curve. And in this video I'm going to show you how to find the derivative function. So first of all, let me introduce you to an idea called limits. So for example, function x, and if x is getting towards a, limit over x to a of that function would be a value that the whole function gets very close to. For instance, the limit of x to infinite of the function 1 over x. So let's draw a table. So if x equals to 1 over x equals to 1. If x equals to 100, it would be 1 over 100. If it equals to 10,000, it would be 1 over 10,000. Therefore, it would be 0. Also because the denominator of the function cannot be 0, so the limit of this function would be 0. And if the limit is changed from infinite to 0, it means that x can be anything except for 0. So in this case, the limit could be infinite and negative infinite. Okay, this concept will be used later in the video, and let's move on to another one. So, as we know that a tangent would be a line that touches a point of a curve, whereas a secant is a line that touches 2 points of a curve. And that is a secant. That is a tangent. So we can find the gradient of a secant by using rise over run, which we've learned in year 8. So if we know the value of these 2 points, we could figure out the gradient of the secant. But what happens if we move one point of a secant close to another? So first, we can have a look at this diagram. So if this is x and this is x plus h, then the point of this one would be x and function x, since we can sub x into the function to get the y value. And also this one, the x value would be x plus h, and the y value would be function x plus h. Okay, let's head back to the question. What if one of the point of a secant gets closer to the other? So in this case, if this point gets closer to that point, the secant will eventually become a tangent, since it's a line on one point of a curve. Okay, if we want to find out the gradient of this secant, we gotta minus the first y value by the second, and we divided the first x value minus by the second x value. And if we simplify this, we will get function x plus h minus fx over h. So that's the gradient of the secant. And remember how we said that if one of the points gets closer to the other, the second will become a tangent. So in this case, when the edge is approaching to 0, the gradient of the secant becomes the tangent. So, in order to find the derivative function of the tangent, we need to make the limit of h be 0. So this is how we find the derivative function of a tangent. We call this the first principle. It can be also written as dy over dx, derivative function of x, and derivative of y. Okay, now let me show you an example of differentiate a function by using the first principle. For example, if we want to differentiate x squared, we need to sub x plus h into x squared. So the derivative function of x squared would be limit h to o x plus h squared minus x squared, since it's a function over h. After that, we can expand the numerator and we can simplify it by cancelling out the like terms. And if we take out h in the numerator and the denominator, it would also be cancelled out. So the derivative function of x squared would be limit h to o x to x plus h. But it's not over. We can sub 0 to h because it's a limit of h, which makes the derivative function of x squared be just 2x. So that's how you find the gradient function or the derivative function by using the first principle. Alright, that's all for today. I hope you enjoyed the video. If you do, please leave a like and subscribe. I'll see you next time.